Okay, so today we're tackling a pretty crucial question in the AI world, and that is how do we actually evaluate these large language models, these LLMs, these powerful AI systems we're always hearing about? How do we know they're doing what they should be doing? We're diving into the world of evaluation harnesses or evals.
Yeah, you're right on the money with that question. With LLMs becoming more and more ubiquitous, more and more everywhere, it is absolutely essential that we have robust ways to assess their abilities, their shortcomings, their limitations.
Totally.
We need to make sure they're performing well. And when we say performing well, that covers a lot of ground, doesn't it?
Yeah.
It's everything from benchmarking different models against each other to making sure their output is coherent, relevant, accurate. And of course, we need to make sure they're not exhibiting biases or generating toxic content.
Absolutely.
So yeah, these evaluations play a critical role in guiding ongoing research and determining whether a particular LLM is the right tool for a specific job. And that's where evals come in. They provide that standardized, systematic approach to evaluation.
So can you break down what an eval actually does? Like what's happening under the hood?
Sure. Think of an eval as a sort of tester ground for these LLMs. It provides a structured environment where we can put these models through their paces. You've got the tasks or benchmarks themselves, the specific problems the LLM has to tackle. And then you've got the data it uses, the data it's trained on.
Okay.
And then, of course, you have the model being evaluated and the metrics we use to measure how well it did. The whole point is to create a consistent, repeatable way to measure performance. And that way, we can compare different models apples to apples. There are a number of tools out there doing this, like the LM evaluation harness from Rule to AI, LLM from Stanford, and even Red Hat has LML as a service. They're all working towards the same goal, which is to really get a handle on how these LLMs perform.
Now, what kinds of tests are we talking about here? What are these models being challenged to do?
Well, evals typically use standardized tasks and publicly available data sets. You might have heard of things like MMLU or human eval.
Yep.
These are designed to test a wide range of natural language processing skills.
Hmm.
Everything from just basic comprehension to more advanced reasoning and even code generation.
Wow.
And the way we prompt the models can also change things up. Sometimes we give them no examples, that's called zero-shot learning. Sometimes one example, that's one shot. Or a few examples, which is, you guessed it, few-shot learning.
Okay.
The LM evaluation harness, for example, is pretty versatile in terms of the model interfaces it supports. You can use it with models from Hugging Face, the OpenAI API, and more.
It seems like there's a lot of different ways to evaluate these models.
Absolutely. And in a broad sense, we can talk about two main types of evaluation: intrinsic and extrinsic.
Okay, what's the difference?
Well, intrinsic evaluation is all about looking at the model's inherent capabilities, kind of in isolation. So we use those standardized tasks and metrics I mentioned, like how accurate is it at answering questions. Extrinsic evaluation, on the other hand, looks at how the model performs when it's actually integrated into a real-world application.
I
Like, for example, if we're using an LLM to analyze customer reviews, how well does it do at that specific task? So both approaches are valuable because they give us different insights into what the model is good at and where it might struggle.
Let's get into some concrete examples. If we're evaluating a model's ability to generate code, what are some of the tools and metrics we're using?
Well, one of the key benchmarks for code generation is human eval, which was developed by OpenAI. It presents the model with a bunch of Python programming problems,
Okay.
and each problem comes with unit tests. And the metric we use here is called pass at K.
Pass at K.
Yeah, and it tells us the probability that at least one of the top, let's say, 5 code solutions generated by the model will actually pass all those tests.
Interesting.
But there's a catch. A high pass at K doesn't necessarily mean the code is like well-written, elegant code. It just means it passes the tests.
Ah, okay.
It might be inefficient or clunky.
Right.
So it's important to remember that even these metrics have limitations.
Right. Okay, how about assessing a model's understanding across a wide range of topics? Like, how do we know it's not just good at one specific thing?
That's where MMLU comes in. It stands for Massive Multitask Language Understanding. It's a data set from Eleuther AI.
Massive multitask language understanding.
Yeah, it covers 57 different subjects,
Yeah.
STEM fields, humanities, social sciences, the whole gamut. And it uses multiple choice questions to test the model's knowledge. It often uses few-shot learning, and we look at the log likelihood, which basically tells us how likely the model's predictions are, given the data.
Okay.
And just to make things even more challenging, there's a harder version called MMLU Pro.
MLE Pro. Okay. So let's say we want to get a more holistic view of a model's capabilities. Is there a go-to eval for that?
Definitely. For a really comprehensive assessment, you'd want to look at HELM, which stands for a Holistic Evaluation of Language Models.
Hey, tell them.
Yeah, and it's developed by the Center for Research on Foundation Models at Stanford. And this thing is thorough. It evaluates models across 42 different scenarios and uses a whopping 59 metrics. So we're talking about accuracy, calibration, robustness, fairness, bias, toxicity, efficiency, the whole 9 yards. HLM really emphasizes standardized conditions for evaluation, and it provides these really helpful leaderboards so you can see how different models stack up.
I'm starting to get a sense of just how much goes into evaluating these models. Now, reasoning is another critical area when we talk about AI. How do we assess a model's ability to actually think through problems?
Right, well, we've got a bunch of benchmarks specifically designed for this, like Big Bench Hard, which is, well, pretty hard,
Okay.
QSMAK for grade school math problems, and ARC, the AI2 Reasoning Challenge.
So are these basically like word problems and logic puzzles for LLMs?
Exactly. And a
Yeah.
common technique here is chain of thought prompting, or COT, where we kind of encourage the model to show its work, to lay out its reasoning steps as it tries to solve the problem.
Interesting. Okay. And finally, when it comes to evaluating reading comprehension, like how well a model can understand and interpret written text, what are we looking at?
Well, there's several data sets for this as well. You've got SQUAD, which focuses on question answering, CoQA for conversational understanding, and HelloSwag, which tests common sense reasoning in sentence completion.
Okay, and so how do we actually measure performance on these tasks?
We use metrics like accuracy, F1 score, and exact match. Basically, we're looking at how well the model's responses align with what we consider to be the correct or ideal answers.
So given all of these ways to test LLMs, how do these evals fit into the bigger picture of artificial general intelligence, or AGI? Like, can these tests tell us if we're getting closer to creating truly intelligent machines?
That's the million-dollar question, isn't it? And it's tricky because there's no universally agreed-upon definition of AGI. It's hard to pin down exactly what it would mean for a machine to be truly intelligent. But some people believe that large-scale benchmarks like MMLU and Big Bench could be indicators of progress towards more general intelligence.
So, like, if a model can perform well across a huge range of tasks, it might suggest a deeper level of understanding.
Exactly. One of the biggest challenges in evaluating for AGI is figuring out how to assess a model's ability to handle completely new, unseen tasks, things it's never encountered before. And then, of course, there's the question of how to quantify things like complex reasoning, common sense, and true understanding.
Right, right.
Our current evals, while incredibly valuable, tend to focus on very specific, narrow tasks. They might not fully capture the complexities and nuances of real-world scenarios or the kind of flexible, adaptable intelligence we associate with humans.
That makes sense. So, overall, what are the biggest advantages and disadvantages of using evals in the quest to understand and improve LLMs?
Well, on the plus side, evals provide standardization, which is huge. It means we can compare results across different research groups and track progress over time. They also allow for automation of testing, which saves a lot of time and effort. They help us pinpoint specific areas where models are excelling or struggling. And they promote reproducibility, which is crucial in science.
Okay, so lots of pros. What about the cons?
Well, we can't ignore the fact that the data sets used in evals can have inherent biases, which can skew the results. And the metrics we rely on don't always capture all the nuances of language, like coherence or factual accuracy. Sometimes models can be specifically trained to perform well on particular benchmarks without truly understanding the underlying concepts.
Ah, so they're kind of gaming the system.
Yeah, exactly. And it's important to remember that performance on these benchmarks doesn't always perfectly translate to real-world performance. Plus, even subtle differences in how we prompt a model can significantly impact its performance, and there's still a lack of complete standardization across all EVL frameworks.
So it's not a perfect system.
No system is, but it's definitely a step in the right direction.
Given all of this, what advice would you give to researchers or developers who are using evals to evaluate their LLMs?
Well, I think the most important thing is to be very clear about your evaluation goals.
Mm.
What are you trying to achieve? Once you know that, you can choose the evals that are most appropriate for your needs. It's also essential to understand the nuances of each metric, what it measures and what it doesn't.
Okay.
And remember that every eval has limitations, so consider those carefully. Don't rely on just one eval. Look at results across multiple evaluations to get a more comprehensive picture.
That makes sense.
And finally, don't forget that automated metrics are just one piece of the puzzle. Human evaluation is still incredibly valuable, especially when it comes to assessing those subtle aspects of language that machines still struggle with.